All right, ladies and gentlemen, welcome back. We're looking at the circulation system, and this is part one. So this one is just going to be pretty straightforward, hopefully, and we're just going to be looking at the heart structure and function. So what it's made up of, the different components, and what it does in each little section. Okay. Okay. So let's look at this. We have four chambers in the heart. As we can see here, we have two atria, and right here and here, and then two ventricles. The two atria are both thin-walled, and they're the upper divisions, whereas the ventricles are the two lower ones. These are the muscular ones, so these you can see the tissue is a little bit thicker, and that's what's actually being compressed in order to push our blood around. Now let's look at the different tissue layers. So there's three that we're concerned with. First of all is the pericardium. So this is the outer shell here of tissue. It's thick, membranous, and it secretes a lubricating liquid. And again, when anything's moving against other moving parts, you need to have this lubricating liquid just like we did in the lungs, otherwise it breaks down. The myocardium, we know that myo means muscle. So the myocardium, it's the cardiac muscle tissue. So again, this is the stuff that is actually being contracted in order to pump our heart. And then the endocardium, this is the inner layer, and this is where there's some connective tissue and endothelial tissue. Okay, the septum, what is it? It's this little division here that separates the left and the right ventricles. But what I want you to think of, and try not to Google it unless you can't figure it out, why would you need a separation in terms of functionality? Why would you need a separation between what's in here and what's in here? Okay, so think about that. That is your job for tonight, to come up with that solution for tomorrow. Okay, so heart valves, we have four of them. And what they do is a valve, as we know when you're opening up taps, it's a valve that opens up and allows something to pass through it. Once you close that valve, it prevents anything from flowing back. So it's really important in the heart. When blood passes through, we don't want it to go back the same way it just came, and so these valves prevent backflow. There's two between the atria and the ventricles, so here, and we call those ones atrioventricular valves, or AV valves, which makes sense because it stands for atrioventricle. They're supported by these things called chordae tendineae, and what it is just some supporting tissue that is attached to these valves that prevent it from inverting. So we don't want the valves to come this way and flip back, because then anything can go backflow and it'd lack the whole point of having them. So make sure we know what the function of the chordae tendineae is. We also call this right AV valve the tricuspid valve. And the reason why we call it that is because it has three little flaps on it. Whereas the left AV valve, we call it the bicuspid, or another name for it is the mitral. Okay, but most of the time people refer to it as the tricuspid or bicuspid. Okay, next ones we have that are between the ventricles and blood vessels. So as you can see here, here's our ventricle, and here's a big blood vessel. So here's a valve here, and then also another one. We'll talk about the blood vessels in a minute. So they resemble half moons, these valve shapes, so we call them semilunar. So it's their pulmonary semilunar, which prevents backflow between the right ventricle and the pulmonary trunk. And then we also have the aortic semilunar, which prevents backflow between the left ventricle and the aorta. Just real quick, if you look at this, the outline structure of the heart, this is considered the right side, and that's the left side. Okay, so it's kind of opposite from what you're viewing, but it's imagining like if you could put your body into this picture and face me, this would be, and that is an enormous heart apparently, it takes up half your body, but this would be the right side of your body and left side. Okay, give you some hair too. All right, blood passageway. Let's talk about the path that it takes. This is going to be pretty tricky because you have to know all the terminology. So we have something called the vena cava, which is here, and it's bringing blood that's used up all of its oxygen back to the heart, and it brings it into the right atrium, which is right here. What it does is the right atrium sends the blood through this tricuspid valve into the right ventricle. And then it gets pumped out this pulmonary trunk to the pulmonary artery, and it goes to the lungs. Once it gets to the lungs, it gets all of this oxygenated blood, and it starts coming back through the pulmonary veins, and it comes into this left atrium. And then that left atrium pushes it down to the left ventricle through the mitral valve or the bicuspid, and then it pumps it out the aorta, which takes it to the upper part of the body or the lower part of the body. Okay, so you might need to pause that to get it all down. Here's a little cartoon for you. Science humor. Not really funny, but just thought I'd throw it in there. So what do we need to know? And just remember, this is the bare bones. We're going to be going over all of this in class. We're going to talk about the 4 chambers. Should be fairly easy. Some characteristics of each. You need to know the 3 tissue layers, and really not more than just what they are. The functions of the septum, which you should figure out for tomorrow. The name of the functions of the 4 valves, and by functions I mean what it's separating. And then this is the big one, it's the pathway. We're going to be doing a little activity to help us remember the different parts of the pathway. Okay? And if you have any more questions, feel free to write them down. Have a wonderful night.